Here's an interesting kinematics problem on projectile motion that was given to the ninth graders who qualified for the 2022 Romanian National Physics Olympiad. And this was problem 1 worth 10 points as all the other problems. So, as usual, if you are preparing for this Olympiad and if you have specific questions that you're stuck on, whether you're 9th grade or 10th, 11th or 12th grade, and you want to see how certain problems are done, let me know in the comments. So for this question, we are dealing with two performers in a circus called A1 and A2. Who stand facing each other on the ground, separated by a distance L. And as you'll notice, there are no numbers in this question, so all the things that we know are based on letters. So we're going to have to solve this problem using symbols. And they perform a circus act by simultaneously throwing small balls of equal size towards each other, like you see in the diagram. So the two balls thrown by A1 and the A2, they start from the same height, and obviously they will land at the same height that they started from. And each of them will have an initial speed V0. Now, V0 is actually unknown, because if you read the rest of the question, you'll notice that for part C, we are asked to actually determine this initial velocity. So we don't actually assume this to be a known value. In this act, the two balls must reach their maximum height at the same time. I'm going to underline this because we're going to come back to it. While passing just past the top ends of a stationary vertical board as illustrated in this figure. The top edge of the vertical board is located at the height capital H above the horizontal plane of the thrown position. So I think this figure is pretty much self-explanatory in terms of what's going on. Air resistance is negligible. The two balls are considered to be point-like objects, and during their motion they do not touch the board, and the thickness of the board is negligible as well. So for part A, we have to figure out the order in which the balls are thrown, and then we have to justify our answer as well. So let's try to understand what's happening. So the two artists, A1 and A2, they throw each of their balls, but not necessarily in the same time, because part A implies that there might be a time delay, and if there is a time delay, we have to figure out, well, we will have to figure that out in part E. And the ball thrown by A1 will pass over this board, which is situated here at half L, or at half the distance between the two artists. So this ball is going to go just above the board, whereas this ball is going to go just below the board. And the height of the board is given as small l, but again, we don't really know this either, because we are asked to determine that length based on things that we know. So what do we actually know so far? Let's actually write down the things that we know for sure, because I kept talking about things that things that are given, but we don't know what they are because they're asked. So realistically, the only things we know are there are three things. So there's G, there's a gravitational acceleration, there is L, which is the distance between the two clowns, artists, whatever, and there's also big H. So big H is the maximum height of the ball coming from A1. We don't know what L is. We don't know what V0 is. We don't know what this potential time delay is either. And we don't know what the angle of, the angle isn't even mentioned, but yeah, we don't even know what that is either. So there's quite a few things we have no idea about, but we have this as a starting point. And actually the question starts quite light, I would say, because it's just asking us to specify the order in which the balls are thrown. And this is relatively straightforward because we can use the fact that, you know, each ball has to travel the same horizontal distance. So the ball coming from A1 is thrown, well, it's shown that, you know, as a steeper angle. So this is going to be V0 cosine of, I'm going to call this theta 1 for now. And this one is going to be theta 2. And we know that they have the same initial speed, which is good to know. And this is V0 cosine of theta 2. So clearly, the time taken by the first ball has to be equal to L divided by V0 cos theta 1, and the time T2 is the same. So L over V0 cos theta 2. So as we can see here, what's happening is that the velocity of the second ball, of the horizontal velocity of the second ball is higher. So V0 cos theta 2 is higher than V0 cos theta 1. And because the velocity is higher, the time taken is smaller. Like this. So if this velocity would reach the top, the maximum height first, it means for the balls to reach the maximum heights in the same time, then this guy has to wait a bit. So I'm gonna say that as a result, so for the two balls to reach maximum height in the same time, A2 must throw the ball later. So the sequence is that A1 throws the ball, and sometime after that A2 will throw the ball, and we're going to call the time delay delta t because that's how the question calls it. I usually call it T0, but yeah, we'll call it delta t in this case. So I'm going to say that A2 will throw the ball with a time delay, or delta t seconds after A1. And this is going to be used in the following equations of motion coming from Suvet. Okay, so that's essentially it. Now for part B, determine the mathematical relationship between the quantities L and H for the described situation to be possible. So what I would do here is I would skip part B. Usually when the question is asking about, you know, find some kind of equation of compatibility or compatibility relationship between certain variables, it might not be obvious how to do it. So what I tend to do in this case is I just ignore it. I just go through the question as normal, and then at some point this mathematical relationship will become obvious. And this is the case not just for this problem, but in general. So for now, what I'll do is I'm going to tick part A because we've done it, and we're going to skip part B, and we're going straight to part C. So for part C, we have to determine the initial velocity V0 with which each performer must throw the ball. So let's focus on A1. And actually, before we do that, there is another interesting phenomenon at play, which may not be entirely obvious, but I mean, it will have to be discussed at some point, which is the fact that those two performers, they are throwing their individual balls with the same initial velocity and with different angles, but the two balls, they both travel the same horizontal distance. So let's actually look at this for a second and, to try to understand it a bit, I would say. So I'm gonna say A1. So this is the equation of motion of the ball thrown by that person, that performer A1. So first of all, I'm gonna pick on the maximum height, which is h. So h is going to be equal to v0, and this is going to be sine of theta 1t minus g over 2 times t squared. So of course, in this case, t is the time till max height. Okay. So if that's the case, we can use the horizontal distance L. We can write it as v0 cosine of theta 1. So that's the horizontal velocity multiplied, and the time to travel that length L is going to be 2t, right? Because if t is the time until maximum height, then the ball is going to take the same amount of time from maximum height to A2, basically. And we can also write this time as v0 sine theta 1 over g. Okay, so in this case, what we could potentially do is we can substitute for time. So I want to get rid of the time in this equation and replace it with what we've got here. So we have that L is equal to v0 cosine of theta 1 multiplied by 2 multiplied by t. So t in this case is v0 sine theta 1 over g, which gives us that L is going to equal to v0 squared over g sine theta 1 cos theta 1. Okay, so I think we can just combine this 2 with this, and this is going to give us sine of 2 theta 1, which will leave us with L is equal to v0 squared over g sine of 2 theta 1. Okay, so let's try to understand this a bit. More specifically, let's have a look at this angle here, at this sine for now. So if we rewrite it as sine of 2 theta 1, that's going to be equal to gl over v naught squared. And the only angles that we're interested in are the angles that are part of the fundamental solutions, basically. So we're just interested. So we're interested in angles for which the argument of sine, so the 2 theta 1, is between pi and 0. Because it doesn't really make sense to say that the ball has been thrown at an angle bigger than 90 degrees. Yeah, I mean, mathematically it makes sense, but not physically. So the only good solutions in this case are actually two. So the first one is 2 theta 1 is equal to arc sine gl over v0 squared, and the other solution is 2 theta 1 is pi minus what I wrote above, which is arc sine of gl over v naught squared. And if we divide this by 2, and well, realistically I could call this 2 theta 2 rather. So theta 1 is going to be 1/2 arc sine gl over v naught squared, and theta 2 is going to be pi over 2 minus the same thing pretty much, 1/2 arc sine GL over V0 squared, which, if you pay attention to it, this is 90 degrees, or pi over 2, minus theta 1, which is an interesting observation. So this tells us the following. If we have to throw projectiles, and if the projectiles have to travel a fixed distance, which is L in this case, and we're allowed to throw the projectiles with the fixed velocity, the fixed initial velocity v0, there are two ways to do that. We can either throw the projectile like this at an angle theta, and the projectile will travel the distance L like this roughly. But there's a different way of doing it, which is, instead of throwing it at an angle theta, we can throw the projectile at the complement of angle theta, which is we throw it with the same velocity, but we throw it at an angle which is pi over 2 minus theta. And if we do this, yes, it will go higher, but it will land in the same spot. And this is exactly the situation we're looking at in this problem, because those two artists, they're throwing their respective balls with the same initial velocity, and the two balls are traveling the same horizontal distance. So the angles are the complements of one another, basically. So this is going to be important moving forward. So if we call this, if we call this angle theta, which this is what I'm going to do actually. So if we call this angle theta, then this angle is going to be pi over 2 minus theta. So this leads to some interesting trigonometric relations, because the initial velocity components, whereas this is v0 cos theta and this is v0 sine theta, so those are all familiar. In this case, because this is pi over 2 minus theta, this is going to be flipped. So this is going to be v0 sine theta, and this is going to be v0 cos theta. You can check this easily with some trig. But anyway, it looks like I've taken a detour from part C, but this will be useful moving forward. Anyway, let's try to do part C. So determine the initial velocity v0 with which each performer must throw the ball. So let's look at the first guy, the person A1. So we know that h is going to be equal to v0 sine theta t. So the same equation that I wrote earlier, except now my angle is just theta for simplicity purposes, like this. L is going to be equal to v0 cos theta multiplied by 2t, and of course t is going to be equal to v0 sine theta over g. So I'm just going to sub this in here and get that L is equal to v0 cos theta times 2 times v0 sine theta over g. Okay, so this becomes, I think, just 2v0 squared over g sine theta cos theta. So I'm gonna keep this for now. I'm gonna call this equation 1, and then I'm going to plug the same t, the same time, into the first equation and see what we get. So we have h is equal to v0 sine theta times v0 sine theta over g minus g over 2. So now this is t squared, so this is going to be v0 squared sine squared of theta over g squared. And we can cancel out some things, so we can cancel out a g, and this is going to be equal to V0 squared sine squared of theta over 2g. Okay, now unfortunately there are two unknowns at this point. So we have our two equations pretty much, which is the one that I labeled 1, and we also have the second one, which I'm gonna label 2. And of course the two unknowns are V0 and theta. So we don't know the initial velocity, we don't know the launch angle, but maybe we can use those equations to figure them out. So let's try. What I would do here is I would rearrange equation 2. So I would do that as follows. So I have h is V0 squared sine squared of theta over 2g. And then I would try to find sine squared of theta, which is 2gh over V0 squared. And I can then say that sine theta is square root of 2gh over V0. So this is fine. We can use this, we can plug it in here instead of this sign, but we also have a cosine, and we can deal with that easily by remembering FTT. So cosine is equal to the square root of 1 minus sine squared. So this is square root of 1 minus 2gh over V0 squared, which turns out to be square root of V0 squared minus 2gh over V0. So we found the sine and we found the cosine as a function of V0. So now we can actually plug them back in equation 1 to figure out what V0 is. So this is L equals 2V0 squared over G, and then we have the sine multiplied by the cosine. So sine is 2GH over V0. Cosine is squared minus 2GH over V0. And then we can cancel out those. And we are going to end up with L equals 2 divided by G, and this is going to be square root of 2GH multiplied by V0 squared minus 2GH. So 2GH times V0 squared minus 2GH is therefore going to equal G squared L squared over 4, and we can then say, or we can then cancel a G, so we can cancel this G with this, and we get this equals GL squared divided by 8H. So V0 squared is going to be equal to 2GH plus GL squared over 8H. And I mean, we can make this look nicer if we want. We can say that V0 is equal to the square root of this. So I'm going to write it as 2GH times, and this is going to be 1 plus. And I believe what's left is L squared divided by 16 H squared, like this. And that should be the answer to part C. So we found the velocity only as a function of G, only as a function of G, L, and H. So we have G, we have L, and we have H. So this is V0. Okay, now let's try to figure out part D. So determine the length L of the vertical board. Okay, so the first artist, A1, he has nothing to do with, well, his equation of motion rather has nothing to do with small l, as you can see. So we also need to use the equation of motion for A2. So just for completion purposes, I'm going to write again the equations of motion for A1. I'm gonna rewrite them. So I said this is going to be equal to, so we have h, which is v0 sine theta t, minus, should be multiplied by t, minus g over 2t squared. Then we have L is v0 cos theta multiplied by 2t. And then we have that t itself is v0 sine theta over g. Now let's look at what happens to the second artist. So the main, well, there are two things about the equations of motion for A2. So first of all, the maximum height is not going to be h, instead it's going to be this much, which is h minus L. So we've got h minus L is equal to, so the other thing is that the launch angle for A2 is the complement with the complement of A1's launch angle, which means that the equations of motion are going to swap sine and cosine. So this is going to be v0 cosine theta, and also there's a time delay. So this guy is not going to throw his ball starting at time equals 0. Instead, he's going to throw it a bit later, more specifically delta t seconds later, which we don't know what that is for now. Minus g over 2, and this is t minus delta t squared. And we also know that the horizontal distance is the same. So we have v0 sine theta multiplied by 2, and the time is the same. And of course, t minus delta t is going to equal v0 cos theta over g. Okay, so we can use this with some degree of success. So we should be able to then figure out what L is just based on what we have here. So I would say that H for the first artist, and also based on what we wrote in part C, so H was equal to this, which was v0 squared sine squared of theta divided by 2g. And you can actually get a very similar expression for A2. So for this guy, it's going to be h minus L equals v0 squared cosine squared of theta over 2g. So now how do we get L out of this? Well, it's relatively straightforward. If we call this equation 1 and this one equation 2, and if we subtract equation 2 from equation 1, we should get L equals v0 squared sine squared of theta over 2g minus v0 squared cosine squared of theta over 2g, which is v0 squared over 2g, and this is going to be sine squared of theta minus cosine squared of theta. Now we're not done yet, because we've expressed this in terms of v0 and in terms of theta, so we have to express everything in terms of things that we know. So this is v0 squared over 2g. So sine squared of theta is therefore based on this. So this is sine theta. Sine squared is 2gh divided by, I believe, v0 squared minus, and then cosine is going to be this squared, obviously, so v0 squared minus 2gh over v0 squared. And as you can see, we can just cancel out this, and this, and L is going to equal 1 over 2g, and we have 2gh minus v0 squared plus 2gh, which is 1 over 2g, and then we have 4gh minus v0 squared. v0 or v0 squared, we found it in part C, so that is going to equal, that's going to be minus, and we have this here. So 2gh 2gh minus gl squared over 8h minus gl squared over 8h, and this becomes 1 over 2g. We have 2gh minus gl squared over 8h, which we can divide by 2g, of course, and we get that L is going to equal h minus L squared divided by 16h, and that is the value of small l. Now that we have this, we can go back to part B. So we've done C, we've done D, now we can have a look at B. So determine the mathematical relationship between the quantities L and H for the described situation to be possible. Well, we know that board has to have a non-negative height or non-negative length, which means that for part B we can just simply state that L has to be greater than 0. So if L is greater than 0, it means that H minus L squared over 16H has to be greater than 0, which means that we can write it like this. Personally, I think this should be enough, but we can, we can write it a bit nicer. And I just realized I put an extra square here. So we can then say that L squared has to be less than 16H squared, or L has to be less than 4H. So yeah, that's it. That's part B. This is what the relationship between L and H has to be for this situation to work. So we've done this as well. And this is what I said at the beginning. It's easier to work through the question and then spot any mathematical relations along the way. For example, it wasn't very clear at the beginning what they meant by this, but now that we got the formula for L, we can clearly see that this should be positive, and we can therefore write this relationship in this way. And that is that's part B. And we have one more thing to do, which is part E. And part E wants us to figure out the time delay delta t. So to do that, I'm just going to use what I already wrote in part D, namely I'm going to use those relations. And for part E, I'm going to call this one equation 1, and I'm going to call this one equation 2, and I'm going to do equation 1 minus equation 2, and this gives me delta t, which is equal to v0 over g times sine theta minus cos theta. And yeah, this should be relatively easy to do at this point because we pretty much know everything. So this is v0 by g, and then sine of theta was root 2h over v0. So that is root 2h over v0, and cosine, I believe, was v0 squared minus 2h over v0. I'm just going to check just in case. Yeah, that's all good. Okay, so again, this cancels, which is nice, and we end up with delta t equals 1 over g, and then we have the square root of 2gh minus, so the issue that we have again, which is not really an issue, but we have this v0 squared, which we have to substitute for. So that is 2gh plus gl squared over 8h. So that is 2gh plus gl squared over 8h, gl squared over 8h, minus 2gh again, and we end up with this. So 2gh minus 2gh, they go. So we have that delta t is 1 over g, and then we have square root of 2gh minus, and this is going to become L, and then square root of g over 8h. Okay, so I think we can also cancel out this, and then turn this into a square root, which gives us that delta t is going to equal square root of 2h over g minus L, and then I have square root of 1 over 8g h. And I think we can technically leave it here, but I'm just going to take it one step further, and I'm going to factorize square root of 2h over g, like this, and it's going to be 1 minus, I believe we're going to be left with L, and then this is going to be divided by 4 multiplied by h. Yeah, and I think this is our final answer. So this is the time delay. So whatever this is, and by the way, we've expressed it in terms of g, h, and L. So whatever this is the number of seconds that artist A2 has to wait before throwing his ball for this situation to be possible. So I think it's quite an interesting question. It's clearly a projectile motion question, and it explores a variety of avenues, and it really makes you think about various kinds of phenomena that occur during projectile motion. So I hope this was clear, and again, if you have any other questions you'd like me to cover on the channel, let me know. But for now, that's the end of the question.